Welcome to Maths for All. I'm Aisling Flynn. This is exam practice. And in this video I have a statistics question worth 25 marks. So part A. In a school, the heights of students are normally distributed with a mean height of 165.3 centimeters and a standard deviation of 5.4 centimeters. Part 1. What range of heights would you expect 95% of the population to lie between? Okay, so let's look for information and keywords that point us in the right direction. So firstly, these words here, normally distributed. So we've seen the normal distribution and we know about the empirical rule. Okay, we'll come back to that in one moment. We're also supplied with the mean height, okay, which is often given the letter mu, okay, and the standard deviation, which is sigma. Okay, what range of heights? So range means we need a from, a starting point, and an ending point. So from and to, so two values. Would you expect 95% of the population to lie between? Okay, so what has 95% got to do with the normal distribution and the empirical rule? So we have learned that a normal distribution is spread around the mean, it's centered around the mean, and from the empirical rule we learned that within one standard deviation, so plus sigma or minus sigma, in a normal distribution you will find 68% of the data. Okay, we learned that if you go out a bit further, so 2 standard deviations above and 2 standard deviations below, this portion of the graph should contain 95% of the data, and if you go out another bit, 3 sigma above and 3 sigma below, that will contain nearly all of the data, and the figure for that was 99.7%. Okay, so review that if you need to. So the 3 magic numbers for normal distributions are 68%, 95%, and 99.7%. So these are values you have to learn. 68% is for plus or minus 1 standard deviation around the mean. 95 goes for 2 standard deviations, and 99.7 is for 3 standard deviations. Okay, so learn those 3 numbers. So we are dealing with 95%, we're looking for a range, and 95% corresponds to within 2 standard deviations of the mean. Okay, so that's where we're going to start. We're going to start with our mean, which is 165.3. and we're going to figure out what's 2 standard deviations below that. So that will be, take away 2 standard deviations, so 2 5.4s. Okay, and when you calculate that you'll get 154.5 centimeters. To get the upper limit of the range, okay, we will add on 2 standard deviations. So that's 165.3 plus 2 5.4s, and you will get 176.1 centimeters. Okay, so 95% of the heights will be between, so write it between. Okay, H is between, H for height. 154.5 is the lower level, up to 176.1, which is the higher level, and I have given a range, a from and a to. Okay, let's check the marking scheme for that. Alright, so there are 5 marks going for that part. Here we have our calculation. So the mean minus 2 sigma, and H is in between, and here we have the mean plus 2 sigma. Okay, and here's the same final values that we got. Okay, so you will get partial credit of 2 out of 5 if you add or subtracted 5.4 to your mean, what you're doing there is you're getting only one standard deviation above or below, okay, instead of two. Okay, part 2. One student is 182.2 centimeters tall. Comment on the student's height with regards to the population. Okay, so 182.2 centimeters tall. So let's recall the mean was 165.3 centimeters and the standard deviation was 5.4 centimeters. So where does 182 come into that? Okay, so we've already seen that 165.3 plus 2 sigma was 176.1 centimeters. Okay, our student is taller than that again. If we were to add on another 5.4, okay, then we get 181.5 centimeters. Okay, so even if we're to look at our normal distribution, even if you go 1, 2 plus 3 sigma, our student here is even past that. Okay, remember that 99.7% lie between plus and minus 3 sigma. So he's really tall. Okay, so we are asked to comment on the student's height with regards to the population of the school. So how can we write some maths, insert some maths terminology or things that we know in here? So we can say that this student is more than 3 sigma taller than the mean. So he or she, will say he is extremely tall or very tall. He's not typical of the population. The word we learned for that is here. He would be considered an outlier. Do you remember that word? So he's not typical of the main body of students. Okay, so he's considered extremely tall. He's more than 3 sigma taller than the mean. So when the instruction is to comment, you can write your answer in English, but try to include some of the maths terminology and use the numbers to help you answer. Okay, so on the marking scheme there was 5 marks going for this. Okay, 182.2 centimeters is more than 3 standard deviations above the mean. So the student is considered extremely tall. Okay, and that's what we had. And you see that there's partial credit going. You can get 2 out of 5 if you write something correct. He is extremely tall, perhaps. Okay. Part B of the question goes as follows. In a press statement from the White House, the government states that 74% of Americans are satisfied with the president's work. The Washington Post randomly surveyed 250 people. 101 people claimed that they were satisfied with the president. Okay, state the null hypothesis and the alternative hypothesis. Okay, so this is a hypothesis testing question, obviously. So the null hypothesis is what we call H0, is what is to be tested. So we have to test what the White House said. The government states that 74% of Americans are satisfied with the president's work. So that is what we are testing. We can write it down. 74% of Americans are satisfied with the president's work. Okay, if we want to write it in mathematical terms, we can say that the proportion of people who are satisfied with the president's work is 74% or 0.74 in decimal. Okay, so either or, you can take the written one or the mathematical one. Now the alternative hypothesis H1 says that this is not true. Now we don't have to give a number with it. We don't have to say whether it's higher or lower. All we have to say that the level of satisfaction with the president's work is not 74%. So we can say the percentage satisfied with the president's work is not 74%. So it's just the contradiction of H0, or you could simply say the proportion is not equal to 0.74. And we don't have to say what it is, we're just saying what it's not. Okay, so that's H0 and H1. So going on to the marking for that one, okay, they've used figures here. 5 marks gone for that. If you get only one correct, you'll get 2 marks. Okay, number 2, calculate the margin of error for the newspaper survey correct to 3 decimal places. So margin of error, and we're asked for 3 decimal places. So we've learned that the margin of error depends on the sample size. If you have a bigger sample, you have a smaller error. And we learned that the error is equal to 1 over root n, where n is how many in the sample. Okay, and in the question here, if you look back, the sample had 250 people, so it'll be 1 over root 250, 1 divided by root 250. So we'll do that on the calculator, and I get 0.632455. Actually no, it's 0.0622, so watch that. And we're asked for 3 decimal places, so after the decimal point I want to include 1, 2, 3 digits, stopping here. Look to the next value. Is it more than halfway or less than halfway? It's less, so my error is more or less 0.063, or if you want to imagine that in percentage terms, multiply by 100, it's equal to 6.3%. Okay, so let's look at the marking scheme for that part. So 5 marks. Okay, 1 over root 250, and we got 0.063. And partial credit, you can get 2 out of 5 if you use the correct formula. If you have the correct formula written but have used the incorrect value of n, or not used n. If you write down your formula on its own, okay, you should get 2 out of 5. Use a hypothesis test at the 95% confidence level to test the White House's claim. State clearly any conclusions. So for this, I think we need the information from the original question. There it is. Okay, so we're asked to use a hypothesis test. We need 95 confidence level. We need an interval for this. So an allowed interval in which the 74% may or may not lie. Okay, so if you look back, you see we're looking for the does the population proportion P, which is 74%, does it lie between the sample proportion, which the sample will give back, the survey, minus the error, and the sample proportion plus the error. Okay, so what do we need to find out? Well, firstly, let's state what's what. P is 0.74 or 74%. Okay, that was our H0, that the level of satisfaction was 74%. Okay, the error from the previous slide we've calculated for 250 people was 0.063. And what's left to calculate before we begin is the sample proportion, or p hat. So from the people who were surveyed, and there were 250 of them, 101 claimed to be satisfied with the president. So we have to calculate this. 101 out of 250 people were satisfied. So let's do that division so that we get a decimal and we can compare like with like. So that gives me 0.404. Okay, that's the sample proportion. So that looks like only 40.4%. Okay, we're satisfied with the president. So let's put that into our interval. So 0.404 minus the error 0.063, and then you'll have that same value 0.404 but plus 0.063. Take care writing down your decimals, include the zeros. Okay, so let's calculate the lower and higher limits of that range. So the first one we need to subtract, and we get 0.341, and the higher one we add, and we get 0.467. So what this says is that the true population proportion, okay, that is satisfied with the president most likely lies between 34.1% and 46.7% based on the sample that was taken. Okay, so what can you say about 0.74? It does not by a long shot, it does not lie within, so inside the interval. So we're not going to accept that 74% as true. We're going to reject it. Okay, so the null hypothesis is to be rejected. Okay, so we send it back, no. So we're saying that it's not 74% that are satisfied with the president's work. Based on the sample or the survey carried out, it seems to be much less. So if you want to write in plain English, less than 74% are satisfied. With the president. Okay. So let's see, have we done everything correctly? Now first notice that was much more work for the same 5 marks as previous parts. So have a go, do your best, but the majority of marks in the maths exam would go for the basic skills. Okay, so even if you don't finish a question out, you may have done quite well. Okay, so p hat is that 0.404, we got that. We did our subtraction and we did our addition and we got the final answer there. Okay, and they say for their conclusion the White House's claim is outside the confidence interval, so therefore we reject. So just if you have the correct words, you get your marks. We reject the null hypothesis. The president's satisfaction rating is not 74%. Okay, so 5 marks going for it. You can get partial credits. You can get 2 out of 5 if you have any correct steps shown. Okay, or like for example calculating p hat. Okay, high partial credit if you got the incorrect p hat but continued otherwise correctly. Okay, or if you omitted, that means if you left out your conclusion, the written part here at the end, you get 4 out of 5. Okay, so that's your 25 mark statistics question.